lab number 3, talk about piecewise defined functions. So the first example is going to be evaluating a piecewise defined function for 3 different values of x. And the key is to look at the value that for x that you're looking for and decide which of these 3 inequalities does that fit into. So we'll start with the first example, f of 0. And 0 is 0 less than -1? No, it's not. So that means we're not going to use the first part. Is 0 between -1 and +2? Yes. So that means for part A, we're going to use 2x. So f of 0 equals 2 times 0. 2 times 0 is 0. So f of 0 is equal to 0. That's how we're going to go about doing this. So part B there, let's say x, this is asking for x's that are, it's 5. So we know 5 is not less than -1, so we don't use this part. We know 5 is not between -1 and 2, so we don't use the second part. But 5 is greater than 2, so we do use x squared minus 4 to evaluate part B. So f of 5, we would plug into part B because 5 is greater than 2. So 5 squared minus 4. That'd be 25 minus 4, which is 21. F of 5 is equal to 21. Okay. Part C, continue the game. -4 is x. We know -4 is less than -1. So that is why we're going to use the first part for -4. So f of -4 equals 2 plus -4, which would be -2. F of -4 is equal to -2. So when evaluating piecewise defined functions, take the number that x that they're giving you and find out which inequality it fits in. Use only that part that goes with that inequality. Okay. So the next example is graphing a piecewise defined function. So when graphing a piecewise defined function, it's important to find the starting and ending points for a particular piece. So what we do is we use the numbers that are in the inequality. So on the first part, part A there, and I'll graph it in red, 2 plus x if x is less than -1. So that means something important is happening at -1. So we're going to plug -1 in for this x right here. So 2 plus -1 is 1. So we know that the point -1, 1 has an open circle on it because it doesn't have an equal to on that inequality part there. So I'm going to go to -1, 1 and put an open circle. And then I just need to pick some x values that are less than -1 to go in here. So if I plugged in a -2, so 2 plus -2 is going to be 0. So I've got the point -2, 0. -2, 0, put a point there. I could continue with this slope, down 1, left 1, down 1, left 1, because that's a +1 slope. And it goes toward -infinity for the x values because that inequality doesn't have a stopping point. It goes from -infinity up to -1. So that's what the first piece looks like. So did that in red. The second piece, I'll work in blue, has 2 important points. One at x being -1 and one at x being 2. Okay, so we're going to plug in -1. 2 times -1 is -2. So we have a point at -1, -2, and then 2 times 2 is 4. So we have the ordered pair 2, 4. So I'm going to go to -1 and then -2, and I'm going to put a filled in dot there because this has that inequality has an equal to mark. I'm going to do the same thing at 2, 4. Filled in dot because this inequality has an equal to mark. We know that that's a straight line because of the form of that part of the equation is 2x. So it's just a slope of 2 there. And that's the second part. Third part has x squared minus 4. So a parabola when x is greater than 2. So I need to know what's happening at 2 in that particular. So that's 4 minus 4, which is 0. So at 2, 0, I'm going to put an open circle. And then I'm going to pick some x values that are greater than 2 to plug into that. So let's plug in a 3. 3 squared minus 4. That'd be 9 minus 4 is 5. So I'd go to 3, 5, and put a point. And I'd go to put a 4 in there. That'd be 16 minus 4 is 10. So I'd go to 4, 10. 4 right there. And I see that it's kind of just one piece of that parabola, x squared minus 4. Okay, so to graph this with the calculator, it's a little bit more difficult because you've got to do 3 separate functions on your calculator. So you're going to have to do one of them. We're going to do parentheses, 2 plus x, 2 plus x, close the parentheses, division symbol, and this is where you're going to put your inequality. X, and then second math is less than -1. So 5, -1. And then if we hit graph, we'll see that portion that we drew in our hand-drawn picture. And then I'm going to hit y equals. I'm going to go to part 2 and graph it. 2x, so parentheses, 2x, close parentheses, division symbol. Then I'm going to put in 2 inequalities with and in between them. So I've got x, second math, is greater than or equal to -1. Second math, go over to logic, get the and then put x is also less than or equal to 2. So x, second math, less than or equal to 2. If I hit graph, I'm going to see those 2 pieces the same as what I've drawn here. And then the last piece, go to y3, and in parentheses, x squared minus 4. Close parentheses, division symbol, parentheses, and then put x, second math, is greater than 2. Close parentheses, hit graph, and there we see that part of the graph that I drew here. We see what's going on there. That piecewise defined function. Finding those important points is key, and knowing whether they're open circles or filled in circles is key to getting the piecewise defined graphs done. So that's Math 110, lab number 3.